So anyone can do it. Keep in mind that you can if you can answer the question, you can get some bonus for the midterm test. Okay, so let's Trần Thế Trung. Yeah.
So the gradient of this, the gradient vector of this will be fx, fy. Have the coordinates.
So okay, so here we have a function g, right? So
yes.
That should be gx,
gx and
e0.
gy. Yes.
Yeah. So this is the representation of a vector in the form of xy plane, right?
Yes. And gx will be y square.
Okay, so that is a derivative, partial derivative with respect to x, right?
Yes.
And we should complete the calculation. Okay.
Yes, it will be
so
1,
right?
Yes.
Okay, and gy
will be 2xy.
Yeah, exactly.
It will be -4.
Yeah, -4. So the gradient vector. Okay, so thank you for your answer. The gradient vector is 1 -4. You see, it's very easy, right? Thank you for your answer. So let me speak in Vietnamese. I will give you maybe 10 minutes more. So tôi sẽ cho các bạn 10 phút nữa thì các bạn sẽ ổn định mic và tai nghe các thứ. Thì sau 10 phút nữa tôi sẽ đọc điểm danh nhé. Mỗi người tôi chỉ đọc một lần thôi. Ai mà không trả lời ngay lúc đấy bỏ qua thì không đừng hỏi, đừng thắc mắc nhé, bởi vì chúng ta không có nhiều thời gian nhé. Các bạn cứ chuẩn bị đi. 10 phút nữa tôi sẽ điểm danh. Okay, so that is a problem 1. So it's very easy to find the gradient vector. You should remember this definition. Okay. So one more chance for this type of problem. The second one. So the given point now is -1 and 2. Okay, so anyone can do it. Let's find the gradient vector. No, no one. Okay, so Nguyễn Quang Vinh.
First we have fx.
So you want to write it, right?
Below and fy below.
Okay, so now let's tell me what is fx.
Fx equal to 1 over square root of 2x plus 3y.
Yeah. So we use the formula of how to say, of the composition function, right?
Yes.
Mm-hmm.
And
then fx at
t0 equal to 1 over 2.
1 over 2. Okay, just put x and y. into the formula, and you can get the value. Okay, so what is Fy?
Y equal to 3 over 2 times square
Yeah.
root of 2x plus 3y.
Yeah, exactly. So what is Fy?
Fy P0 is 3 over 4.
3 over 4. Okay, so thank you for your answer. So finally, we have this green vector. That's good. Thank you. So you see, it's not difficult to remember the formula of the green vector. That is the examples for two variable function. You can do the same for the more than two variable function. That is a problem 3 and 4, but we will skip it. Now let's take a look on the problem 5, where we need to find the directional derivative. So we are given a two variable function g of this form, a given point p0, and furthermore we have a vector. So the question now is, let's calculate the directional derivative of g at p0 along the direction of the vector u. Okay. So so I will help you to do this one to remind you what is a directional derivative. When you say about the direction, keep in mind that the direction should be a vector, a unit vector. That that vector should have module 1. So to find the direction of the vector u, you should normalize. So let's see. I denote the vector v is a normalization of the vector u given by this formula. So I think it's not it is. I think it is familiar with you because I'm pretty sure you already seen it from the linear algebra. So here, the module of u is given by this, right? And you multiply with the vector u. So I and j here is the notation of the normal vector of the x and y axis, right? And it gives you, I'm not sure, but if I remember correctly, so help me to correct if I do anything wrong. Okay, so here is the unit vector of when you want to calculate the directional derivative. And now here is the notation of the directional vector, directional derivative. You can see with the vector v is a direct direction, g is a function, and p0 is a given point. And this is the notation of directional derivative of g at p0 along the direction v. And it is given by this formula. It is a scalar product of the green vector g at p0 and the direction v. So that is, this formula is the reason I told you that you should be careful, because in this formula the vector v should be a unit vector. So if you put the given vector into this formula, you will get the wrong answer. Okay. So from here, you see we need to calculate the two vector. The first one we already have, that is a vector v. And now let's take a look on the gradient vector g. So we come back to the previous two problem, right? So again, gx p0 and gy p0. So anyone can help me to complete this calculation? Okay, anyone can do it? No. We already have the formula of g. You just need to find the partial derivative with respect to x and y. Okay. Let's find what is gx. So here is the function. It is if we want to find the partial derivative with respect to x, we need to consider it is one variable function of x, and y should be considered as a constant number. And now that means we should use the quotient rule here, right? Yes, I will do it step by step. That is, the number one is a derivative of the numerator. Okay. So it gives us 2 plus y square over 2xy plus 2 square. Now let's use a assumption on p0 to get gx. Gx as p0 is equal to, we have 3 on the numerator and we have 1 square. So we have gx p0 is 3, right? And gy, okay, so the derivative of the numerator is -1. This gives us -2 minus x squared. So gy p0 equal to -3, right? We already find the component of the gradient vector. And now we conclude it. 3 minus 3. So that's time to finish the problem. The directional vector derivative of g at p0 is given by the scalar product of two vectors. It is 3 multiplied with 12 over 13 minus 3 multiplied with 5 over 13. So we have here 21 over 13. Okay, do you see? So let's take a look on it. Okay, so let's take a look on it, and in the meantime, now I will check. Please focus on if you hear your name. Bạn Đức Anh.
Có.
Lại Hải Anh.
Có ạ.
Nguyễn Ngọc Linh.
Có ạ.
Chu Văn Nam.
Có ạ.
Phạm Trường Sơn.
Có.
Đặng Văn Tuấn. Trần Đăng An.
Có.
Trần Minh Anh.
Có.
Vũ Quỳnh Anh.
Có ạ.
Nguyễn Nhật Anh.
Có.
Đỗ Việt Anh.
Có.
Đỗ Duy Anh.
Có.
Lê Đức Anh. Nguyễn Phan Gia Bảo. Phan Thanh Bình. Phan Thanh Bình. Phạm Khương Cường.
Rồi.
Có.
Đỗ Tuấn Dũng.
Có.
Lại Đức Thịnh.
Có.
Nguyễn Minh Trí. Give me a minute. Nguyễn Minh Trí. Trần Hữu Trí.
Có.
Nguyễn Văn Trọng.
Có.
Lê Thành Trung.
Có.
Nguyễn Đức Trung.
Có.
Bùi Quốc Trung.
Có.
Mai Quốc Trung.
Có.
Vũ Thế Trường. Đặng Đức Anh.
Có.
Bạn trả lời sớm nhé. Tôi đã gạch tên bạn rồi đấy.
Vâng, xin lỗi ạ.
Lại Hải Anh. Nguyễn Ngọc. Này vẫn là Nguyễn Ngọc Linh à? Có lớp này có hai Nguyễn Ngọc Linh à?
Không, thầy điểm lại ạ. Điểm lại rồi ạ.
Này, chết rồi, này bị lỗi à?
Thầy vừa bị điểm danh là em đã Đức Anh, em điểm danh lần đầu rồi, em giật mình.
Ok, không vấn đề, tôi chắc cái tờ này bị lỗi rồi. Nhưng mà để tôi
Thầy
xem
ơi,
lại.
có Trần Minh Anh chưa? Lúc nãy
Lớp
em thấy thầy
này-
đọc của Trần Minh Anh xong thầy dừng. Em không biết thầy đã đọc bên anh chưa?
Trần Minh Anh đọc rồi mà.
Em thấy có Trần Thế Trung chị ạ.
Có rồi, bạn vừa mới trả lời đúng không?
Vâng.
Em thấy thầy kiểu đọc mỗi bạn một lần thôi thì em không biết là thầy có nghe được em hay không. Tại vì có bạn trả lời thì hay không thầy vẫn đọc.
Thế
Sao
em
cơ?
Nguyễn Duy Anh Tùng điểm danh đấy ạ.
Đợi chút, đợi tôi một chút.
Vâng.
Cứ đợi tôi một chút. Để tôi lấy cái danh sách. Bởi vì là cái tờ này nó bị lỗi. Tức là mỗi bạn tôi chỉ đọc một lần thôi, vì nó không có thời gian đâu. Cho nên là nếu các bạn không trả lời ngay thì các bạn không có mặt thôi. Thì tôi đã nói ngay từ đầu mà. Mọi người chuẩn bị mic các thứ cho nó cẩn thận. Vừa tôi đọc đến Vũ Thế Trường rồi đúng không? Rồi, bạn Vũ Thế Trường vừa tôi đọc là không có tên, bây giờ tôi đọc sang tờ tiếp theo nhé. Ngô Anh Tú. Nguyễn Xuân Tú. Nguyễn Minh Tuấn. Nguyễn Đức Minh Tuấn.
Có.
Nguyễn Thanh Tùng.
Có.
Nguyễn Hoàng Tùng.
Có.
Đặng Việt Tùng. Đặng Việt Tùng hay là Đặng Việt Tùng nhỉ?
Đặng Việt Tùng có.
Ok. Dương Thanh Tùng. Nguyễn Việt Tùng.
Có.
Nguyễn Minh Tùng.
Có.
Nguyễn Duy Anh Tùng.
Có.
Nguyễn Đình Việt Vinh. Nguyễn Đình Việt Vinh. Nguyễn Đăng Vinh. Đặng Hoàng Vũ.
Có. Có.
Ok. Nguyễn Xuân Minh Vũ.
Có.
Bùi Lê Nhất.
Có.
Ok. Cảm ơn các bạn.
Thầy ơi, thầy điểm danh xong rồi à?
Xong rồi.
Thầy chưa đọc tên em ạ.
Tên bạn là gì?
Nguyễn Quang Vinh ạ. Hình như thầy chưa đọc tên mấy bạn trên 11 ạ.
Bởi vì là các bạn đã vừa trả lời đúng không?
Vâng ạ.
Bạn trả lời rồi thì tôi đã nốt vào rồi thì không cần phải đọc nữa.
Không, cả những bạn khác thầy ạ. Thầy
Bạn khác là bạn nào? Có 2 bạn thôi mà. Từ đầu giờ có 2 bạn trả lời thôi mà.
Không, em nhớ là lớp có bạn Nguyễn Văn Tuấn học cùng em trên 11, thầy chưa đọc tên ạ. Mấy bạn mắt sinh viên TA 11 ạ, thầy bị mất đấy ạ.
Nguyễn Văn Tuấn á. Tôi thấy trong này là L2.7 thì có bạn là tên là Nguyễn Đức Minh Tuấn đấy chứ. Ở trong tờ danh sách này không có bạn nào tên là Nguyễn Đăng Tuấn cả. À đâu, Đặng Văn Tuấn gì?
Đặng Văn Tuấn.
Đặng Văn Tuấn tôi nhớ tôi đọc rồi mà. Tôi đọc rồi. Tôi đọc và không có ai trả lời cả. Ok. Tiếp tục nhé. Thế là cái tờ thứ 2 thì nó bị mất thôi, chứ còn tờ đầu tiên thì đầy đủ ở đây rồi. Và tôi đã đọc tờ thứ 2 rồi đấy. Rồi. Okay, so we continue. I hope you have enough time to take a look again on how to find the directional derivative. So let me recall it one more time that we should be careful, because when we say about the direction, we need to normalize the given vector. Okay, let's see which problem to do next. So I think about the directional derivative, that is enough. If we have enough time, we will come back to the type of program. So let's change to the problem of writing tangent line equation. Okay, that is a very important property of the gradient vector. So let's take a look on the problem 8. So we are given this level curve and a point P0. So let's write the equation of the tangent line of this level curve at P0. So this level curve is nothing but the circle with the center is the origin and the radius is 2. Okay. So let's take a look on it. Here is the level curve, right? What is the point here? The point P0 should be here. And we need to write down the equation of this tangent line, right? And we know from the lecture that the gradient vector at P0 of this level curve is orthogonal to the tangent line. That is the gradient vector. I denote this function by fxy. Okay. We know that it is very important property of the gradient vector. It is orthogonal to the tangent line. So it will give us the equation of the tangent line. Okay, so let's take a look on how to write. Of course, if you remember the formula on your lecture note, you can immediately write out the equation of the tangent line. But now I will show you more detail to write out the equation. Anyway, the first step, we need to find the gradient vector at P0. So anyone can help me to do it, because it's very easy. Anyone want to try? No? Okay. So I will write down it here. If you have any question, you can stop me, okay? So fx0 that is a gradient vector. So I take a point Q with the coordinate x, y belong to the tangent line. Then from my remark, the vector P0Q and the gradient vector of f at P0 are orthogonal, right? The two vectors are orthogonal. That means we have this product equal to 0. Okay. It is equivalent to this. P0Q is nothing but x minus square root of 2, y minus square root of 2 multiply with what we had from previous calculation. Okay. So from the linear algebra, you know that this product can be computed like this. Okay, so it is easy to get the equation. And this is the equation of the tangent line. Okay. This formula is exactly the formula from the lecture note to write out the equation of the tangent line. Okay, let's take a look on it. If you have any question, you can ask me. Okay. that is the problem of writing tangent line equation. So now let's consider the next type of problem. You know, when from the calculus one, the derivative of a function give you the rate of change of the quantity represented by the function, right? So so there is a natural question about can we determine in which direction the quantity changes most rapidly, and in which direction the quantity changes most slowly. Okay, that is the problem of finding the relation of maximal rate of change and minimal rate of change. So let's take a let me see what is the problem. Let's take a look on the problem 7. We are given this two variable function of f of x and y, and a given point p0. So we need to find the direction in which function increase and decrease most rapidly. Okay, of course at p0. So it is very important to remember that the function f increases most rapidly in the direction of the gradient vector. So let me write down it. Okay, and it decrease most rapidly in the opposite direction of the gradient vector. Minus the gradient vector. Okay, so we need to find the gradient vector, of course. We repeat what we have done before. So what is fx? That is 2x plus y. Then the fx at p0 equal to -1, right? And fy is 2y plus x. Then fy at p0 is 1. So the gradient vector of f at p0 is -1 and 1. Okay, but you cannot say that the direction is this vector. We should normalize. So the direction in which the function increase most rapidly is this unit vector, given by normalizing the gradient vector at p0. So very easy computation. Okay, this one is the answer for the first question. And for the direction of decreasing most rapidly at p0, you should take the -u, which is this vector. Okay. So is there any question about this problem? Okay. So I think I have enough time to show you something about the linearization. It's just a matter of remembering the formula. So in calculus 1, you already know that you can approximate the value of a function f around a given point by using this formula, and it's also called the Newton formula, right? That means for x close to the number a, then you can approximate the value of f at x by using this linear formula. This formula. For the multivariable function, we also have a very similar very similar approximation using the gradient vector instead of the derivative. So for example, for two-variable function, you can approximate the value of the function f at the point x, y, which is close to the point a, b, by using this formula. Okay. So you can rewrite this one by this. So the right hand side is called the linearization of the function f at AB. Okay. So let's take a look on the problem 18. We are given the two variable function f x, y, and the given point. So we are asking to find the linearization is nothing but the right hand side of this formula. Okay. So anyone can try it? Don't want to try it? Okay, so let's see. We first need to calculate the partial derivative or the gradient vector of f at the given point. Let's consider the first case of 0, 0. Fx is 2x and Fy is 2y. So in this case, P0 equal to 0, 0. Then the gradient vector of f at P0 is 0, 0 vector. So the linearization is, and in this case, we have f0, 0 equal to 1. So it is f0, 0 plus this gives us just number 1. The second case, then we can calculate the gradient vector, which is 2, 2. The value of f at 1, 1 equal to 3. So the linearization in this case is 3 plus this product of the two vector. This one. Just give us this. So here is the linearization for the second case. Okay, so do you have any question? Any question? Okay, so if there is no question, we can stop the class here. See you next week.